Today, I'm going to show you how to connect and code an ultrasonic sensor. This ultrasonic sensor is basically a little sensor that lets out sound and senses the sound as it reflects back from an object. And then you do a little math and you can find out how far away the object was based on how far or how long it took the sound to get there and back. Very simple. The device has four pins that come out of it. VCC, which is power. Trig, which is the trigger to start the signal. Echo, which senses the signal. And ground, which is just ground for the power. Connect these to the Arduino very simply. The ground goes to the ground. The power goes to the 5 volts out. And trig and echo go into any of these pins basically. Just pick a random one. I chose 11 and 12. Okay, and here's the code that we have. So in the start, we set pin 11 and pin 12. Trig pin is trigger, echo pin is echo. I just saw some examples online that use the words trig pin, echo pin. You could literally just say trig or T or E, whatever you want. Just say int, and then whatever you want it to be named equals whatever pin you want it to be. Long duration, this kind of just sets it up as a variable that we have duration, centimeter and inches. Void setup, serial begin, we have to add this in here if we want it to print out into the serial monitor, which is this. If we click on this and we plug in the sensor, it will put out the distance so we can see it. Because I don't have a LCD or anything connected to it, there's no way to know what the distance is. It'll just be getting distance and you won't know what it is. By plugging it into the computer, it will output it onto your screen. Pin mode trig pin output and pin mode echo pin input. We're setting the trigger pin as an output, so the Arduino is sending a signal out from that pin, and from echo pin it's expecting a signal to come in that it's going to analyze. Alright, so we have the loop here. This is just what's going to be going on constantly. So if you go to manufacturer specifications, you need to have a high pulse of 10 or more microseconds for the sensor to work. So basically that's where this comes in. Delay microseconds 10, so we have it on high, which is sending out a signal for 10 seconds. This right here is just something I found online. People say just to delay, have a low status before it goes to a high, just so that it kind of has a little break between the pulses. But technically we could get rid of this and put in the delay microseconds 5 after this here, and only the very first time it runs, it will kind of run right away, but it doesn't matter. That's just kind of like a little housekeeping thing that is not absolutely necessary. Okay, so then we have the signal from the sensor is going to be coming in. So we have pin mode, echo pin input. We already have this written up top, so technically you could just delete this. We don't need that. Then duration equals pulse in. So this is just kind of defining what duration is. Duration is the pulse in, which is a signal coming into the input from echo pin high, and then high just sets it up to be ready to receive. And then so we're going to convert this distance, the time that it takes something to come in, the duration, into a distance, into centimeters or inches, because that's more useful. Because it says 0.04 seconds. That doesn't mean much to us as a distance. So we have to do some math and we have to come up with this. Centimeters duration and inches duration. So centimeters equals duration divided by 2 divided by 29.1 or multiplied by 0.0343. Let me show you how I got that. Okay, so just a simple solution to this is we have this the speed of sound, which is 343 meters per second, but we want centimeters because this machine only runs like from 3 centimeters to like 450 centimeters. So meters is a little too big of a value, and seconds, the computer runs in microseconds. So we have to convert seconds to microseconds and meters to centimeters. And this is pretty simple. If we go onto Google, you could type it on Google, or you could do simple division, and you get 0.0343 centimeters per 1 microsecond. So then if we go back to our drawing, if this is our sensor, sends a signal to the object, the signal comes back, So if it takes 1 second to go there and back, it's going to be times 1. But then we want half of that, because if it takes 1 second, it takes half a second to go here, half a second to go back. So we want to know the half a second, the distance it takes the sound to go half a second, because that's the distance from here to here. That's going to be the half a second, and then another half a second to go back. So basically we're just going to take the distance, which we'll do distance divided by 2, so half of the distance, and then we'll multiply that times 0.0343, and that's going to give us a distance in centimeters. And then we could do the same in inches. You could just find out how many inches per microsecond the speed of sound is. So that's how we got these two. Here we just have the distance divided by 2, so that's the time it takes to go one direction, not there and back. And then we do divided by 29.1. It looks a little prettier than multiply by 0.0343, but it's the same thing. And then serial print inches. So if we plug it in, the best way to show you is by plugging this in. So one limitation of this is it doesn't work well against soft objects. So against my hand, you can see it's kind of jumping around. So it works sometimes, but against hard objects it's pretty good. So against my screen here, it's not jumping up to like 1,000. And the supposed range, let's go across the room here. The range is supposed to be about 450 centimeters max. Anyway, it's simple as that. So you can get this connected, and then using the values I output from this, you can use it to control different things. I want to use it in my next project here is to control this remote control car. That's a bit of a mess, but to control this so that when the power goes in, or when we have a certain distance, maybe I can put an object in front of it and it can maintain the distance. So if that object gets closer, it'll back away. If the object gets farther, it'll move closer to it. Or maybe it could turn and we can put a couple sensors in each direction and it can maybe do a maze on its own. So different ideas. I think they're all pretty cool and fun. So hope you enjoyed. I hope you learned something from that. See you in the next one.